Ricochet from a meteorite impact on Earth created a huge field of craters that so far, we have only seen examples of on other planets. The unique site in southeast Wyoming has more than 30 craters that were formed about 280 million years ago, researchers said in a new study. The craters were created after a meteorite impact hundreds of miles, or kilometers, away blew boulders of bedrock into the air. The trajectories indicate a single source and show that the craters were formed by ejected blocks from a large primary crater, study leader Thomas Kenkmann, a geologist at the University of Freiburg in Germany, said in a statement from the Geological Association of America, which published the new research. Secondary craters around larger craters are well known from other planets and moons, Kenkmann added, but have never been found on Earth. Close to home, for example, lunar secondary craters pepper a region of the far side due to the proximity of four source craters, Finsen, Kármán L and Antoniadi. The area came under scrutiny from the Chinese Chang'e 4-moon lander. In addition to 31 craters the scientists have firmly identified as secondary features, the team spotted more than 60 other contenders. When researchers first spotted the zone of craters, they suspected an asteroid, or space rock, had broken up in midair and sent rocks crashing into the ground beneath its path. Individual craters range between 32 and 230 feet, 10 and 70 meters, in diameter, the researchers said. Further examination showed that several of the craters are clustered in small areas and several are elliptical, rather than circular, which suggested a different origin story for the features. The craters also appear to be aligned along ray-like patterns, suggesting that these are secondary craters all formed by debris flung out around a central, primary crater made by the original impact. But finding that source crater will be a difficult task. The team's work suggests the crater is deeply buried in sediments, somewhere near the Wyoming-Nebraska border in a region called the Denver Basin. If scientists can ever track it down, they expect the source crater would be roughly 31 to 40 miles, 50 to 65 kilometers, across. For comparison, the crater in the Yucatan Peninsula associated with the end of the dinosaurs about 3 times the diameter, at about 90 miles, 150 kilometers. All of the secondary craters were due to bits of bedrock that were roughly house-sized, between 13 feet and 26 feet, 4 to 8 m, across, according to the researchers' calculations. The original impactor, they say, could have been more than 1.2 miles, 2 kilometers, wide.